So welcome to this Fika, the SystemC Fika. It's number 3 in our series. We have these as intermediate events during the year, and we also have the SystemC Evolution Day, which is the bigger event. And of course, we have the DVCons, I should say, the different conferences where we also find SystemC in the organization by Accellera. So since this is an Accellera meeting, sort of, I have this standard slide here to show that, yeah, so it's okay to whatever we talk about here is subject to inclusion in possible future versions of the SystemC standard. So this is a picture of the page for this event. The page is on systemc.org. There is also where you can find a registration, which you obviously have found, which gives you the link to this WebEx. So I'm Ola from Ericsson, and in the team organizing this, we also have Martin from NXP, Jerome from ST, Christian from Cadence, Mark from GreenSox. Unfortunately, I think Mark couldn't make it today. And we have Peter from Intel. For this Fika, we said that we should have a theme. So the theme today is SystemC parallelization. And that is a dear topic for many. There are many papers and many contributions in this area. And we thought it would be interesting to gather some of them and have a talk about these aspects in this meeting today. So we have the first meeting is Mathieu Moy talking about SE During. Then we have Tanguy Sassola from France. Both are from France, the first ones, talking about an approach called Scale. Then we have Jakob coming from Intel talking about CIMIX. And we have Professor Rainer Dörmer from California talking about RISC, a compiler for parallel SystemC. So I should say that these are people that we have in this meeting. We do not claim to cover the whole world of SystemC parallelization, of course. There are many papers and many people that are not represented in this list here. But this is what we have today. So the idea is to have some small presentations. Let's see how every individual presenter wants to do it. If there is like a mini Q&A perhaps in each of these, you can do it how you wish, you present us. And then we have a reserved time slot at the end for some discussion. And if you, I can just show you, if you go to this page, you will find links to abstracts, and they are actually closer, further down on this page. So you can see a small abstract from each presenter. So this is really nice that we have gotten this input. So we have a small abstract here, and we have a URL linking to either an article or a paper or some page with more information. So we have a little collection here of results where people can browse and read more. Let's see if I need to do this again. So we are here, right? So I will say super quickly some words about this, and then I will just let the first speaker start. We have SystemC, and this is just to put up some topics that are challenging, I think, for the one who wants to do this in parallel. We have SystemC with the processes, and of course one might think that run these processes in different Linux processes or Linux threads. And that is perhaps easier with SystemC if you communicate with channels. But then someone invented TLM and even TLM2, and then people start to call functions in the other module, and they have a more direct communication. And we have DMI, which is then even more direct. You just peek into the memory of the next guy. And moreover, these different initiators, they run ahead of each other. They have their own local time. And since this is all C++, every programmer can do whatever tricks he wants in C++. So there are, of course, many potential dangers for concurrency problems here. So when you try to figure out how to make this a parallel system, there are many things to think about. As we know from concurrency, we need to make things thread safe so we don't mess up data. We need to figure out how the different processes shall synchronize, etc., etc. And we need to think about communication. And if we propose something here, do we do it with a standard SystemC, or do we do it with a modified SystemC? And when we introduce concurrency, how do we view determinism? Do we claim that our simulation runs the same all the time, or not? So I put this up as just slogans, and then we might want to think, is this of interest or for Accellera? So I keep this as sort of slogans, and we might return to them perhaps when we do the discussion at the end. I will make a teaser for this one, and I will repeat it at the end. This is the next Fika, where we have a theme that we call safety-related use cases for virtual prototypes. So this is about simulations where we want to meet and talk about what can one do when you simulate not only the traditional digital and electronics with processors and want to verify that the software works as intended. What if you also want to investigate and perhaps verify that some safety aspects can be predicted or analyzed using such a simulator that we call virtual prototype, or a virtual platform, as some people call it. So I want to say this to invite everyone who are interested in this topic to contact us and propose or submit contributions for this next Fika. And the tentative date is then the 15th of September. So I will put these slides after this meeting at the site, or I will ask Martin to do that. So you will find this also after the meeting. If we go back to the agenda, we have the first presentation now coming up, and that is Matthew Moy with SC During. So I will leave it over to you, Matthew, and ask you to share your screen.